In this lecture, we will discuss about triangles. Triangle is a closed figure made up of three intersecting lines. It has three sides and three vertices. Three angles are also inside that. So first we see, if a triangle is drawn, then these are three line segments. We say three intersecting lines or line segments. So three angles, three sides and three vertices. But normally when we say the elements of a triangle, we say there are six elements. Six elements, under that three sides and three angles. But if we notice, this triangle is made up on a plane figure. So it's not in the air. So we will say it has some area. So the seventh element is area. So this is one element. We can say altogether triangle has 7 elements. We are not discussing the area right now. We'll discuss and focus on these 6 elements. So when we say three angles, on the basis of the angles, first we will classify the triangles. Okay. So triangle has different types. First is acute angled triangle. Acute angled triangle means all three angles are less than 90 degrees, like this. This is an acute angled triangle. Second is obtuse angled triangle. Obtuse angled triangle has one angle greater than 90 degrees. It has one angle greater than 90 degrees. So if you draw like this, any one angle, this angle, here angle B is greater than 90 degrees, so that is why it is an obtuse angle triangle. The next is right angled triangle. Right angled triangle has one angle equal to 90 degrees. So right angle triangle can be drawn like this or like this. One angle should be 90 degrees. Next is equilateral triangle. Equilateral triangle means a triangle whose all three sides are equal. If we observe an equilateral triangle, all three sides and all three angles are also equal. Next type is isosceles triangle, a triangle whose two sides are equal. And when two sides are equal, if we are taking these two sides equal, then the base angles will also be equal. The theorems are based on isosceles triangles also, that we will do later. So isosceles triangle, any two sides can be equal. Here I have taken these two sides, maybe like this. These two sides equal, then these two angles will be equal. Or if we are taking these two sides equal, then these two angles will be equal. So these are isosceles triangles. Then next is scalene triangle. It means the three sides all are unequal. That is called scalene triangle. When we draw this triangle, then we can say AB is not equal to BC is not equal to CA. When all three sides are different, unequal, it means the angles will also be unequal, means they are not equal. There is one more type, which is combination of two. That is called isosceles right angle triangle. Means it is a right angle triangle whose two sides are equal. So always remember, hypotenuse cannot be equal to any of the sides. It means the perpendicular and the base. This can be base or this can be base, okay? Or this can be perpendicular, this can be perpendicular. So any two sides are equal except the hypotenuse. So this type of triangle is called isosceles right angle triangle. So these are the types of triangles. They are acute angle triangle, obtuse angle triangle, right angle triangle, equilateral triangle, isosceles triangle, scalene triangle, and isosceles right angle triangle. So when we talk about a triangle, in this topic we will discuss about the properties and we will discuss about the congruency here. So next is, we will say what is the meaning of congruency. If there are two line segments, two angles, or any two type of figures, two circles, two squares, there are different ways to see the congruency. So first we'll understand what is the meaning of congruency. Congruency means any two figures or more than two, if they are equal in all aspects. Means if they are line segments, their length should be equal. If they are angles, their measures should be equal. If they are squares, their sides should be equal. So we will discuss some figures in which I will tell you how to check the congruency of different figures first. Then we will go to triangles. So these are three line segments. If we notice, if I have given this is x units, this also is x units, and this is y units. So since the length of this AB and length of this CD, it is equal, that is why these two line segments will be congruent. And one more concept is there. If we overlap or if we superpose this AB on CD, AB will cover this CD completely. But if you will keep this AB on this EF, then it will come till here, X only, and this BF is left out. It means this AB is not covering this EF fully. So AB and EF cannot be congruent. So what is the criteria for line segments for being them congruent? Their length should be equal. And if I draw two angles, and the measures of these two angles are theta, and suppose if I draw another angle which is alpha, so this theta is suppose 60 degrees and alpha is 75 degrees. So the measure of angle will decide whether the angles are congruent or not. So this angle is congruent to this, and both of them are not congruent to this third one. So here the length and here the measure of that particular angle. Now some more figures we will discuss first. These are squares. Squares means all the sides are equal. But if I say this is x and this also is x, so ABCD is congruent to PQRS. But this EFGH, since the side is y, so all three are of same shape, but the size is not same. So these two are having the same shape as well as same size. That is why equal size. That is why these two are congruent, and they both are not congruent to this third one because the size is not same. So similarly, next is interesting. If I say there is a rectangle and there are two concepts. First we will discuss about the dimensions and then area. What we saw, the squares were congruent and so their areas will be equal. Now if we discuss the rectangle, this is one rectangle, its name is ABCD. Another rectangle I have drawn, PQRS, and this is also a rectangle. If we ask or somebody asks, what are these figures? We'll simply say These are rectangles, opposite sides are equal, each angle is of 90 degrees. So this is the definition of rectangle. So we can say that these all are rectangles. But are they congruent? It depends on the length and the breadth. So here, if the breadth is x, here also the breadth is x, the length is y, the length is y. So these two rectangles are congruent. And they both are not congruent to this one, although all three are the rectangles. So what matters for a rectangle? The length and the breadth. But if I say there are 4 rectangles and the area of these 4 rectangles is 24 square centimeters, all 4 will may or may not be congruent. I'll give you the example. 24 square centimeters. Since 24 can be written as 24 into 1, 12 into 2, 8 into 3, 4 into 6. So I can take one rectangle with the sides 1 and 24. I can take a rectangle of size 12 and 2. I can take another one with the sides 8 and 3, and I can take 4 and 6. If you observe the area, here the area will be 24 into 1, 24 square unit means centimeters. Here also if you take 12 twos are 24 square centimeters, 8 into 3 will be 24 and 6 into 4 also will be 24. All 4 are having equal areas, but they are not congruent. I said they may be. Maybe another rectangle I am drawing, which is 4 and 6. So these two are having equal areas as well as corresponding length and breadth are also equal. Since the length and breadth are equal, that is why they are congruent, not because of the area. Okay? So any two figures, if they are congruent, their areas will be equal. But if any two figures are given or more than 2, their areas are equal, they may or may not be congruent. Now we will discuss about congruency of triangles. There is a variety. There are different axioms and theorems based on congruency of triangles, because there are different types of triangles also. So first we will just see one situation. If I draw 2 triangles, any 2 triangles, and one of its sides is 3 centimeters. Will they be congruent? No. So I discussed 6 elements with you. Now we will see how many elements are required to prove the congruency of 2 triangles. Similarly, if I say I have drawn 2 triangles, this is one triangle whose one angle is 60 degrees. And another triangle is there whose one of the angles is 60 degrees. So by taking only one angle, we cannot decide that the triangles are congruent or not. So we can easily say the triangles are not congruent. If I say, take a triangle with one angle and one side 3 centimeters. Take another triangle with one side 3 centimeters and one angle 60 degrees. Means one side and one angle also will not decide about the congruency. Now suppose I have taken 2 sides, 3 centimeters and 4 centimeters, and here I have taken 3 centimeters and 4 centimeters. Then again these 2 triangles are not congruent. What does it mean? It means that we require at least 3 necessary and sufficient conditions so that the triangles will become congruent. So there are some criteria. First is, if two sides of a triangle are equal to two sides of another triangle and the angle included between those two sides, if that is also equal, then the triangles will be congruent. So this is one of the axioms. Axiom means a proven statement which is not to be proved, or you can say it is universal truth. We don't have to prove it. So it says that if two sides, first axiom, SAS means a triangle. If two sides of this triangle are equal to any two sides of another triangle, it means like this, and the angle included means between these two sides. So this is the must condition, that angle B should be equal to angle Q. So we will say in triangle ABC and triangle PQR, if AB is equal to PQ, BC is equal to QR, and angle B is equal to angle Q. I have written in this order. Before we write it, we have to check that the sides which are given equal, the angle included should be equal. This can be written in any order. There is no hard and fast rule that you have to write like SAS only. We will call it SAS. That will be shown with the help of figure. But this order we can write in any way. But when we will write it, then we will say, so by SAS, which says side, angle, side. This is side, angle, side. Means the angle is included. When we write the congruency, then it is to be written in this form. Triangle ABC is congruent. This is the symbol for congruency to triangle PQR. Now here it is very important to write the correct order. This correct order is based on one concept called one-to-one correspondence. Now what is this one-to-one correspondence? That we will see when we have observed the parts. What I said, the necessary and sufficient conditions. So what we have seen, the first condition, that minimum 3 elements of this one triangle should be equal to 3 elements of this triangle. But what are those 3 elements? It is not like that any 3 elements and any 3 elements. No. Whichever element you are taking here, the corresponding element you have to take for this triangle also. So that is called one-to-one correspondence. It means when this triangle ABC is equal and congruent to triangle PQR, it means we have to be very careful with the order. It means this vertex A corresponds to vertex P. Similarly, B with Q, C with R, and so the other elements also. Other elements means angle A will be equal to angle P, angle B will be equal to angle Q, and angle C will be equal to angle R, and other 3 elements. They are AB will be equal to PQ, BC will be equal to QR, and AC will be equal to PR. So what is important? Important is the one-to-one correspondence, means the order. A if you are taking, its corresponding part is P. And if you are taking B, if you are taking the order ABC, here it should be PQR. But if you are writing this triangle ACB, then this will be written as PRQ, because A is having one-to-one correspondence with P. So when you are writing A, you have to write P. If you are writing B, with that you have to write Q. So you just look at this order, ABC, PQR. So this is called SAS, axiom. It means when two sides of a triangle and the included angle. Very important is that included angle. If any other angle will be equal, it will not work. So this is an axiom which says two sides, one included angle equal to two sides and included angle of the other triangle. Then these two triangles are equal and congruent. Now there is a theorem. It is called ASA, means angle, side, angle. When the name says angle, side, angle, it is understood that the side is included between two angles. So if we take two triangles, this is the second part, which is actually a theorem. First was an axiom. So in this theorem, the name is ASA, or you can say angle, side, angle. So if we look at two triangles ABC and PQR, in which two angles, means any two angles. Suppose we have taken this angle B is equal to angle Q and angle C is equal to angle R. And the name says the side should be included. So between these two angles, which side is included? BC. So BC is equal to QR. Now, by this, it is said if two angles and included side of a triangle is equal to two angles and included side of other triangle, then the triangles will be equal and congruent. So what will we write? In triangle ABC and triangle PQR. This is not the proof. I am just giving you the symbolic form that how can we apply the congruency ASA in any two triangles. In the questions you can apply this ASA. You have to observe two angles and included side. So in these two triangles, what is given? Angle B is equal to angle Q, angle C is equal to angle R, and BC is equal to QR. So by ASA, wherever we will be using, we have to mention the condition over there. So the triangle ABC is equal and congruent to triangle PQR. Now there is one interesting thing about it. Suppose this side is not included, then will the triangles be congruent or not? Let's see. This is ASA, clear? Now, if suppose I say this side BC is not equal to this, any other side is equal. Suppose I say AC is equal to PR, okay? Not BC and QR, which are the included sides. Then what happens? Means angle B is given equal to angle Q, angle C is given to angle R, and it is given that AC is equal to PR. But in a triangle, if two angles are equal to these two angles, the third angle will automatically be equal. Why? Because the sum of three angles of a triangle is 180 degrees by angle sum property of a triangle. So if any two angles are given equal, automatically this angle is equal. But if we do not discuss this third one, then also there is a criteria called AAS. It means that any two angles and any side may be included, may not be included. Then too the triangles will be congruent. And the reason is what? Automatically the third angle is equal. So you may say ultimately it can become ASA also. But if you are not taking that ASA, then there is a criteria which is called AAS, which says that if any two angles of a triangle is equal to 2 angles and any third side, not included one, any side of this triangle is equal to the side of this triangle. So this will be written as a corollary. AAS, the triangles are equal and congruent without discussing this third angle, because this is also one of the criteria. Okay, so we can use either ASA or AAS. The third is SSS, means side, side, side. The sides of one triangle are equal to the sides of another triangle, then both the triangles will be equal and congruent. Now, short form is SSS. It is actually side, side, side. Till now what we have seen? Axiom SAS. Second theorem we have seen ASA. And one corollary, that is AAS. Now the third one, SSS. A triangle ABC and a triangle PQR are such that AB is equal to PQ, BC is equal to QR and AC is equal to PR. So what we will write? In triangle ABC and triangle PQR, what is given? AB is equal to PQ, BC is equal to QR and AC is equal to PR. Then the triangles will be equal and congruent. Okay, so 3 sides and 3 sides. Automatically the angles will also be equal. If you want to use, you can use that also. After this, the fourth one is for the special type of triangles which are right angled triangles. That property, that theorem is for right angled triangles. That is called RHS. So, the fourth one, RHS is not right hand side, it is right angle, hypotenuse, and side. So particularly you have to take 2 right angled triangles. So if ABC, which is right angled at B, and PQR, which is right angled at Q, if this is one factor, that is right angle, hypotenuse, and any one side, AB can be equal to PQ or BC can be equal to QR. Any one side we have to take. So suppose we are taking AB is equal to PQ. So what will we write? In triangle ABC and triangle PQR, 3 elements are there. That is, angle B is equal to angle Q and also mention that it is a right angle. Then AC is equal to PR, also AB is equal to PQ, right angle, hypotenuse and side. So triangle ABC is equal and congruent to triangle PQR. When I said that by applying these axioms or theorems the triangles are congruent, third we have seen SSS and this is RHS. If we observe the triangles which are congruent, we are discussing how many parts. We will concentrate on that first. We are discussing 3 elements. Now, how many elements we have got? 6. It is not important and not necessary that we have to prove all 6 elements of one triangle equal to the 6 elements of other triangle. What have we seen? We have taken only 3 elements. But which 3 elements? We have taken 2 sides included angle, 2 angles, any 2 angles and side, whether included or not included. We have taken 3 sides and we have taken a special condition for right angle triangles, that one right angle, hypotenuse and side. But if you see the other combinations possible are AAA or the opposite of this AAS. Is it true? No. I'll give you the example. Any 2 triangles which are equilateral triangles. What does it mean? That each angle 60 degrees. Here also, since it is an equilateral triangle, are they congruent? No. So congruency cannot be proved by AAA. So these are also 3 elements, but it will not give us the congruency. Later we will discuss about similarity when we will do the similar triangles. Then they are similar. So 2 equilateral triangles which are equiangular also can be similar but may not be congruent. Similarly, SAA. We take 2 angles and 1 side. We write it like that, SAA. We write it as AAS, not SAA. Clear? So, if I say, is there any theorem like SSA? Because these are also 3 elements. Or ASS. This, when I am saying SAA, you have to write it in the form of AAS. We don't write it as SAA. Any 2 angles, one side is always written as AAS, and when the side is included, it is written as ASA. But any 2 sides and 1 angle, no. And any 2 sides and 1 angle, either write in this way or in this way, these will not give us the congruency, and this is actually AAS. So what we have seen, the triangles which can be congruent by taking 3 elements, but not any 3 elements. These are the specific ways how can you take 3 elements to prove the triangle is equal and congruent. Now, when the triangles are congruent, then what? If I say that these 2 triangles are congruent by S, A and S. Okay. How many elements I have taken? 3. What about other 3 elements? If a triangle is congruent to the other triangle by a particular criteria, suppose here I have taken SAS, it means I have taken 2 sides and 1 angle. What is left out? Left out is this third side. This third side, and 1 angle is taken in consideration. So what is left out? These 2 angles. Will they be equal? Yes. If any 2 triangles are equal and congruent by one criteria, by taking 3 elements, automatically other 3 elements will be equal by the concept called CPCT. This is the short form which stands for corresponding parts of congruent triangles. What does it mean? That whatever criteria we have applied, other than that whatever is left out, those will become corresponding parts. So here one side and other 2 angles will become corresponding parts. So by CPCT, those 3 left out parts will also be equal. So many places you can see this CPCT. CPCT is not any theorem or axiom. CPCT is whichever three parts we have taken, other three elements will be equal by this concept called corresponding parts of congruent triangle.